If you head over to versal.com, you see a bunch of these cool SVG drawings and animations all over the website, and they tend to use these pretty heavily to advertise some more of their abstract features like server-side rendering and AI generation. And a fantastic example of this is this globe towards the bottom of the website here. And this is a single SVG that uses no CSS or JavaScript, including all of the animated sections as well. So in this video, we'll reverse engineer exactly how they've achieved this, and then we'll rebuild our own version of this globe. In doing so, we'll cover a bunch of interesting features like animation along a line, gradients, and masking. So if you want to learn all of this, we're going to cover it in this video. So the first thing we need to do is work out exactly how they've done this, and we can do that by just copying the SVG and inspecting the code. So we inspect element, find the root of the SVG, do edit as HTML, and we can just copy all of that and then paste it into our text editor. So once that's pasted in, if you just drag the file into the browser, it will come up looking something like this. So it kind of looks broken at the moment. We can see these pulses come in, but that's about it. We don't see any of the other lines. And the reason for this is that most of the colors are defined through CSS variables. So we just need to define those as well. And since I was looking at Versal in dark mode, I've just set the background color to black. And then we need to set two CSS variables. So define a root element and then set the guide color to HSLA 0012 and 1, and then the color to 00EAC5. Once we've set that, if we then look again, we can now see the globe itself and all of these glowing elements as well. So for the globe itself, we could just draw it in Figma, export as an SVG, and then just render it in our SVG code. But then we need to work out exactly how these glowing elements are done here as well. So if we look back at the code, we'll see a bunch of these radial gradients defined everywhere, and they have IDs. These seem to be randomly generated, so it looks like Versal must have generated these automatically. But here, we define the gradient itself, and then the animation for the gradient, so how it changes over time. Now, these gradients won't actually render on their own. They need to be set as either the background color or the stroke color of other elements. So if we copy this ID here, you'll see we have another reference for it, and that is for the stroke color of one of the paths. So this is the reason that we have these paths glowing here, because actually what's happening is there's a radial gradient that we only see sort of masked on the path itself. And to get a much better idea of what's actually going on there, at the top, if we define a massive circle that will fill the entire canvas, so set it to CX0, CY0, so it will start in the top left, and then set the fill color to one of these gradients. And you do that by defining it as a URL and then pass in the ID of the gradient using the hash. Set the radius to something massive so it fills the entire canvas. And then if we save this and then refresh, you'll see we see the gradient in its full glory now. So it enlarges, follows the path along, and then shrinks when it gets to the end. If we then go through and grab the IDs for all of the different radial gradients, and then render a circle for each individual one, which I've done here, just comment this one out, and then re-render again, we'll see all of the different gradients following each individual line. So this is exactly how they've achieved this effect, but rather than it being rendered as the fill color of a circle, they're rendered as the stroke color of a bunch of different paths. So again, if we look, we can see the stroke color here for this path. If we just change this to red instead, you can see now this is just red. But if we change it back to the gradient, we now have the gradient animation instead. So we need to work out a way to replicate this in code without having to manually write all of the radial gradients and the animations. And we can do that in the next step. So I'm just over in Figma here because we need to draw the SVG itself, so the background globe and then the individual paths to be able to animate the gradients across. Now, the easiest way to do this, if you want to line it up perfectly, is just to print screen the globe on the Versal website, drag it onto here, and then just overlay the lines on top of it so we can get our own SVG. The easiest way I found to do this is just to use the ellipse tool, draw it once, and then copy it. And then you can hold down the Option key and then drag, and it moves both sides at the same time, and then line it up in all the correct positions. And then we need 4 ellipses, so 1, 2, 3, 4. We need the line down the middle, and then all of the horizontal lines here as well. Once you've done that, just position it correctly on your canvas. In this case, I've got a canvas that is 600 width by a height of 428. So group all of that together, and then down at the bottom here, we'll see export. Select SVG and then just export as SVG. Once you've done that, we'll see our SVG export here. And if I open it in text edit, you'll see all of the SVG code. We just need to copy this into our application now, and then we can start to see it rendered on screen. So I'm inside Cursor now, and I've got a small React application so I can actually render this SVG. I've just bootstrapped this with Vite, so if you want to do the same or whatever build tool you want to use, go ahead. And I've just defined the root level of the SVG, and the view box is the same as the dimensions I mentioned in Figma. And then I've also set the style to 100% width and 100% height, so it just fills the canvas. And then all I'm rendering at the moment is this component called background, and this is the actual SVG globe itself. So if we just copy this into the background component, we'll end up with some code that looks like this. All I've done here is replaced the SVG tag at the top with a group tag, because you can't render an SVG inside an SVG. And then we've just kept the same dimensions, so a width of 566 and a height of 304. And then all we need to do is add a transform tag to just position that correctly on the canvas. So if we look in Chrome, you'll see this is the rendered globe, and it's actually clipped off at the bottom. So we're not rendering the entire globe, it's actually pushed slightly down. So just tweak these numbers to position the globe correctly. And the way I actually got this 17 was if we go back into Figma and then hold down the Option key, you can see the 17 pixels of padding and 124 pixels of padding at the top. So that's how you actually get those values in the first place. Once we've got the actual globe rendered, we then need SVG paths for the individual sections that we want to animate the gradients across. So if we unhide these, you can see I've drawn individual paths for all of the different routes that the gradients would take. We need to individually export these as SVGs and then also pop them into our application so we can start to animate the gradients across in a second. So if I look back at the code, I've defined an array called beams here, and each of the paths is one of the exported paths from Figma. And then I've just given it the IDs glow 1, glow 2, glow 3, 4, 5. And then we just set the XY position so that they would be positioned correctly on the canvas. I've not actually rendered these yet, we'll do that next. And I found the best way to make sure that these are literally pixel perfect is just to copy the section that we want to create the path for. So I'll copy this ellipse here. Let's move this up. Set this to red just so we can see it. Let's hide all of these. So we've got the copied ellipse. We can just double click into it so we can access the path itself. Now we've got all of these sections, we can start to delete the bits that we don't need. So click this, delete, click this, delete, and then I'll press P, pop a section there as well, and then click this bit, delete, and then we have remaining the exact path that we need. So once we've got all of these, it's a little bit tedious to do, we can then just come out of the path, go back to export, choose SVG again, export them all as individual SVGs. We then have all of these individual paths, so we can just copy the value of the D attribute. We'd go into cursor, and then we just paste that path onto one of the elements of the array. Just repeat this for all of the individual paths, and then we'll have all of the sections we need. Now let's do a quick refresher on SVG animation, because you can implement animation with SVG without any CSS or JavaScript at all. And you can do this by using the animation tag. So here we just got an SVG element, which has a view box of 1000 by 1000. And then I've just set the width to 100% and the height to 100%. Then we draw a circle within that SVG. Its CX, so its X position is going to be 100 and its Y position is 100 as well. It's got a radius of 10 and a fill color of red. And then nested within the circle, we define an animate tag. We specify which attribute we want to animate. In this case, we're going to animate across the X axis. we specify the duration of the animation, so 4.5 seconds. We say that the repeat count is going to be indefinite, so it just loops forever in this case. And then we say which values that we want to animate between. So in this case, the x-axis will animate between 100 and 1,000 pixels across 4.5 seconds. So if we head over to Chrome, you can see now that we have this red ball animating from the left all the way to the right. And that just loops indefinitely. And then we can repeat that same logic again for the y-axis as well. So again, it's exactly the same thing, except this time we're targeting the cy attribute, and all of the other arguments are the same. But with that in place, now the ball moves diagonally because we're animating both the cx attribute and the cy attribute at the same time. You can also do this for radius as well. So in this case, the attribute name is just r, and the values are going from 10 to 50. So the start radius in this case was 10, and we're just going to animate up to 50. So with that in place, we get a diagonal animation, and the radius grows as it goes down. Now we can use this exact same technique to animate along a path as well. All we need to do is find the individual points in the path that we want to animate to, and then adjust the cx and the cy animation accordingly. So it either goes up or down or left or right. And then that way we can move along any arbitrary complex path. But writing all of this by hand would be extremely fiddly and tedious. But luckily, there's a really simple function that we can write to pretty much automate the entire thing. So here we have a complex path, and this ball is following the path perfectly. So let's check out the code to see how this works. First, again, we define an SVG element. In this instance, we've just got a smaller view box, but I've defined the path itself. So this red line here, which is just a squiggly line that I drew in Figma. Then we define the circle. In this case, it's blue. And then again, we define two animate tags for the cx attribute and the cy attribute. We set both to have a duration of 10 seconds and to loop indefinitely. And then we have values and key times defined, but this comes from a function we defined at the top here, getPathAnimation, passing in the same path that we used to draw the path itself. Now this function returns all of the values that we need for this animation to work, the x values, the y values, and the key times. So just like we had in the simple example, the values here we just had 2, but we could just extend this, so we could go back to 500 and then to 100 again. And that's what this function is doing. It's just returning to us a large array of values that allow us to ultimately adjust the X and Y position independently, so this animation occurs. Now, if we take a look at getPathAnimation, we first just pass in the path, and then we pass this to a function called SVG Path Properties. This is from a library called SVG Path Properties, and it's basically a JavaScript implementation of what's available on SVG elements anyway, but it can work in Canvas and Node environments. So depending on where you're rendering this is a pretty good library to import, so it works in more environments. On this, we have a method called getTotalLength, and this will just get the total length of the path. So say the total length is 500 for argument's sake. We then define how many individual steps we want to break that path down into. So if we were to break this down into, say, 10 steps, the animation is much more jagged. It just jumps around, and it doesn't really seem like it's following the path at all. The upside of that, though, is that we have way less values rendered within our animate tag, but the animation is not as smooth. If we increase this to, say, 1,000, we get a super smooth animation, except from the SVG is now huge. So you want to kind of find a middle ground that gives you smooth animation and a reduced SVG file size. So with 100, that looks pretty good. Then we define 3 arrays, 1 for the X values, 1 for the Y values, and 1 for the key times. We then go through a for loop for the amount of steps that we have. And then the first thing we do is get the key time. So the key time always needs to be a value between 0 and 1. And to do that, we can just divide I by steps. So if steps was 10 or 100, by doing this, we'd always get values between 0 and 1. So if we look at the key times here, with 100, we have 0, 0.01, 0.02. If I set this back to 10, now the key times is 0, 0.1, 0.2, all the way up to 0.9, and then 1 again. We then call path properties again, getPointAtLength. We then pass in the length at which we want to get the point for. So by timesing key time by length, it means that we're just going to grab a point along this path broken up into the individual parts that we defined in steps. So in this case, we'll have 100 points plotted along this path. So from the point, we get the X coordinate, the Y coordinate, and then we can just push in the key time as well, and then just return all of these values. And then once we've got them, we can just apply the X values to the X animation, the Y values to the Y animation, and both of them just have the same key times as well. And then it's these two tags combined which give us the smooth animation to move this ball to any point within the SVG. So again, I'll set this back to 100, and this is how you can animate any element along a path. So we'll use this technique now to animate our gradients along the paths that we've previously defined, and then mask that gradient to the paths. And then we'll end up with this effect, which is just using the exact same technique of moving elements along a path. Okay. Not only do we need to move the ball along a path, but we also need to increase the radius as well, because if we look, not only do we need to move the ball along the path, not only do we need to move a gradient along the path, but we also need to increase its radius as well. If we look back at the original Vercel SVG, and then add these circle tags back in, we can see that the gradients enlarge, follow the paths, and then shrink when they get to the end. So we need to replicate this same process with our own algorithm. So there's two small adjustments that we need to make. First is that we need to add a radius animation to the circle as well. So we've got our CX and our CY animation. We also need to add an animation that targets the R attribute, which is radius. We'll make sure that this matches the same duration, 10 seconds, and then we'll set values and key times to cause the radius to change only at the start and at the end. Looking at the key times between 0 and 1, between 0 and 0.1, the radius will turn from 0 to 25, and then from 0.1 to 0.9, it will stay at 25. So that will be the entire course at which the ball's moving. And then at the very end, between 0.9 and 1, we animate back down from 25 to 0. This will then correspond with some changes that I made to get path animation. So these are the additions that I added, and you could do this in many different ways, but I figured this was the most readable for the context of this video. We first define a new variable here, hold steps. So if we break down the animation into 100 steps, we're saying that 10 steps at the start and 10 steps at the end is when the radius animation is going to occur. So we're not going to move the ball. To keep the ball held in place for those 10 steps, we just find the start point, find the end point, and then for the amount of hold steps, so for 10 steps, we push the start point, the start X and Y, to the start of the array, and we push the end X and Y to the end of the array. And you can do that with unshift and push, and with that in place, we end up with an animation that looks like this. So the ball grows, then it animates along the path and maintains its size, so there's no change to the radius at all. And then when it gets to the very end, then the ball shrinks. And that is much closer to what we see in the Vercel animation. We can now just reuse that same function, but instead of moving a circle along a path, we move a radial gradient along a path instead. So the difference between these two functions is, here we're animating a circle, and here we're animating a radial gradient. So define the element radial gradient, I give it an ID of gradient, and then importantly, you need to set the element gradient units equals user space on use. If you don't do this, then the gradient will not be the correct size. So make sure you add that element in. We need to specify what the gradient actually looks like. So we add two stop elements. We'll say that we'll start with red and then end with a red at 0% opacity. And then we have the same animate tags for CX, CY, and radius. And then for the path, rather than the stroke just being red, we set it to URL hash gradient. So the ID matches the ID here. Give it a stroke width of 2. And then with that changed, we end up with an animation that looks like this. So you can see now we've got a gradient moving along the line instead of a circle. So we just need to now apply this to our globe animation, and everything should start to look pretty similar to how it did on the Vercel website. So if we look back at the globe animation, I've added the same function to the top, get path animation, and we've added the same hold steps to make sure that we can animate the radius while the ball doesn't move. Then if we look at the main globe component, we still have the array of beams, and we render them on a loop to render a new component called beam. We pass in all of the information so that we can render those correctly. So if we look inside beam, we call in the same function, get path animation. We get the X values and the Y values, and we don't need key times in this case because if you're doing a linear animation, then key times is actually optional. We render a group tag so we can position each path in the correct place. We then render the path itself, specifying the actual path, the stroke being again the ID that matches the gradient. We set the stroke width to 2, and then we have the same radial gradient that we just showed in the previous example. We have the stop colors, we have all of the animations, including the radial animation. And with all of this in place, we now have a globe that's starting to look pretty close to how it did on the Versal website. Now, I've made a few tweaks to how this radius animates and to how the get path animation looks. So instead of having 100 steps, we actually only need 5 because it doesn't matter too much if the animation is more janky when you're using gradients. It's not obvious when we're only masking on a thin line like this. So we only have 5 steps. The hold steps either side is just 1. And then I've just tweaked the radial gradient down here to have values 0, 75, 75, 0. And then on the key times, we've got 0, 0.15, 0.85 and 1. So this was just me manually tweaking these numbers until the animation looked pretty good. The only thing left to do now is to add these pulse animations. We need to add these little circles in and have this circular pulse come out. And we'll do that in the final section. The last part that we need to do is to add these little circles that have this pulse that comes out of them, like that. So if we look back over at the code, just as we had an array of beams here, we now have an array of nodes. And each node has an ID and an X and a Y position. The best way to find out what these positions need to be is if we head back over to Figma, just align a box along its top left corner in the position that you want the center of the circle to be. So in this case, we've got 70 and 352. And then if we go back over to the code, we've got 70 and 352 there. So that will be the center of the circle since we're changing the radius. You just then need to find the position of all the places that you want to render a circle. So just move a square to all of those positions and then get the coordinates. And once you're happy with it, we then render a new component down here called node. If we look into node, again, we're using a group tag and we set the transform position, translate with the X and the Y. And inside this, we draw 2 circles. The bottom circle here is the one that's permanently rendered. So it's a black circle with a gray border. So this is the one we see on screen here. Then the top circle, this is the actual pulse. So to do this, we draw a circle, we set the stroke color, we set stroke width. These are all CSS variables. So the SVG guide color in my case is 00EA-C5. Then we set up 2 animate elements. The first targets the radius attribute, and we use the letter R for that. It has a duration of 4.5 seconds, an indefinite repeat count, and it changes the radius from 0 to 30 pixels. The second one changes the opacity. So the attribute name is opacity. We have the same duration, the same repeat count, but here we change the values from 1, 1, 0.5, and then 0, 0. Just as before, I tweaked these values manually until I got the animation that I was happy with. So you can either copy what I've done or adjust it slightly until you get the effects that you prefer. And that's how you can recreate the globe from the Versal website. If you want to see more tips from me, like how I would build an entire SaaS as a solo founder, then check out this video here. You might also enjoy it. But thanks for watching, guys, and I'll see you in the next one.